We will be discussing the deep dive into O-RAN architecture, and hopefully you'll gain a lot more understanding of the O-RAN itself. Yan. So I've mentioned during the overview of the Learning Hub course, no, we will cover the O-RAN architecture and the relevant specifications, particularly the evolution of the RAN, and then the cause of that, or the motivation of that is the disaggregation of the hardware and software components. No? Because originally, most of the components are proprietary. They are very vendor specific. So if one component needs to be changed, what happens is they have to also update all the other components, no? So isa sa mga motivation talaga is yung financial aspect, no? If magastos yung capital expenses, yung CapEx, then the operators will also have limited na opportunities to upgrade, and of course that will translate no sa less na coverage for the subscribers. So what they want is that move towards open architecture so that no it's easier to interoperate and makapag-update ng mga gamit. Pwedeng yung software na lang yung palitan or pwede isang portion lang ng hardware ang papalitan, no? Kagaya nung nakita niyo doon sa pinakita ni Richard earlier, no, may mga commercial off-the-shelf devices lang, and then inside would be the software, no? Yeah. So this is also taking advantage of the virtualization no, initiative ng a lot of different na systems, no. Since lahat no slowly nag-virtualize na talaga. So ito po ay also towards that goal, no. Ayan. Okay, so Open RAN considers not only open remote radio unit, the one that is nearest the end user. This is the one containing yung ating antennas, yung nag-change no, ng analog to digital and digital to analog conversion. And then the baseband unit, no, it's the one nearer to the remote radio unit, no, but medyo malayo-layo pa na sa core unit. No. So itong dalawang to mostly, usually, no, they're in the RAN part, no. Sometimes near the cell site, no, some are pwedeng nakapool somewhere else. No. So not only these two components, no, pati yung interfaces connecting the components, no. Like may interface connecting these two and the other interfaces, no. So yan po yung titignan natin mamaya sa architecture, no. Ano-ano pa po yung mga iba't ibang components and ano-ano pa yung mga interfaces, no. Then finally, yung mga ini-introduce na new components no of the O-RAN Alliance, no. So meron tayo nung sa RIC, yung near real-time RIC and non-real-time RIC, and then other interfaces as well, no. So valid the original na architecture is from 3GPP, and then it is modified and added no components to allow interoperability no by O-RAN Alliance. No? Okay, so let's proceed siguro po no to the topics. And siguro let me skip sa ibang slides kasi since we only have around 45 minutes, no. So this is the review no of the different RAN earlier, no. From 2G, 3G, and then currently at 5G, no. In Philippines, we have 5G network already, but in limited na cities and places, no. So you can check no kung saan po makikita yung mga current na deployments, no. Meron kasi tayo ditong link, no. Siguro let me copy this link. Sige. Let me, ano lang, saglit. Copy ko and then I'll share to you so that you can check po in a bit, no. Ayan. Okay, so let me type sa chat. Yan. So you can explore this later, no, and depending on the location, no, there are different mobile coverages like 2G, 3G, 4G, 4G plus, no, ito po yung towards 5G na, no. Parang ito yung LTE advanced, no, in Philippines, ito yung LTE. Then 5G is yung new yung NR, no, new radio natin, no. So nakalagay diyan nung nagtry sila to check yung coverage no, on the different roads, no. Some have 5G coverage, some have 4G plus, and possibly dun sa mga medyo mas remote locations pa na baka 2G lang yung available, no? Yan. So, this one, you can see, no, if in your place, no, baka meron kayong 5G na, no, or baka in some provinces, no, baka hanggang 2G lang. Yan. Okay, so marami pong iba't ibang parang cell sites, no, or parang iba't ibang RANs, and at different generations, no, iba yung mga names nila to differentiate them, no? So in 2G, we have the GSM Edge or GERAN. So this is involving the base station controller and base transceiver station. Pagdating sa 3G, no? So originally 2G nakafocus lang sa text, digitized na call, no? Actually may 1G din, but in 1G nakafocus kasi sa analog lang na calls, no? And hindi pa siya digitized and hindi encrypted. Pagdating dito, it's already digitized and pwede na maglagay ng encryption, no? Hindi na basta-basta matatap at maririnig yung conversation, no? And then in 3G, we have here UMTS, no? UMTS is Universal Mobile Terrestrial System, no? And then the name of the RAN is UTRAN. There is a radio network controller, and yung tinatawag na natin yung parang base station is yung Node B, no? So ito, no, Node B, yung kanyang pinaka base station, no? And then for 4G, we have LTE, long-term evolution, and then the RAN is called EUTRAN, and then the base station is known as eNode B, no? Then next one is 5G, no? Yung new radio, it is called as 5G RAN, and then the base station is called as GNode B. So in the architecture later, no, you might find na may mga discussion na eNode B, GNode B, Node B, and so on, no? So these are the base stations, no, for various components or various cellular generations, no? Nag-iiba-iba yung mga names nila, no, at different generations. Possibly, no, pagdating ng 6G, which is planned, no, to be deployed by 2030, no, by the 3GPP, no, then may different name din sila, no, for the base station there, no. Ayan. Okay, so ano pong significance nito, no? Kasi we need to understand this RAN, no, para maintindihan na why there are changes in our cellular networks, no. Ayan. So siguro let me skip, no, dun sa RAN architecture evolution. So the main motivation for having a RAN architecture for the evolution of the radio access network is the disaggregation, no, of the system into smaller systems, no. So originally, the main parang diagram of the telecommunications network would involve the core network, ito, the transport network, and then the radio access network, tas papunta na sa UE, sa user equipment, no, via radio frequency, no. So usually in the past, no, magkasama lang po, no, sa isang box or parang isang equipment, both yung hardware and software ng RAN, no? Specific yung software dun sa hardware na yon. So pag nasira, kahit yung software or yung hardware, then kailangan palitan siya as a whole, no? And then ganun din yung kapag nag-upgrade kayo to another, maybe, or change to another vendor, pati yung mga other components would also change kasi hindi sila open pa, no, in the past, no? Yan. And then eventually, no, yung later we'll discuss the different RANs. They change, no, into parang smaller subsystems, no. Yung RAN, hindi lang siya isang big na block, no, but rather there are smaller blocks inside, which we'll discuss later, no. And it was easier, no, eventually parang naging natural na evolution lang na maghiwa-hiwalay even pati yung hardware and software, no. Yeah. So when we say disaggregation, this means separation of the hardware and software. And since ang discussion natin is Open RAN, no, naka-focus lang tayo dito sa disaggregation ng RAN component, no. So yung pinaka-component ng telco natin that is nearest the end user, no. Okay. So yung disaggregation of the hardware and software, no, started not only in RAN, no, it also happened in other systems, no, due to, of course, the improvement of the technology, yung hardware lumalakas, no. Previously mahina yung mga computers, tapos yung mga servers hindi rin ganun kalakas pa before, but eventually they get more and more powerful. And then that started yung mga virtualization, no, ng mga iba't ibang components, no. Yan. Okay, so let me go to the different RAN architectures, no. So we have here the traditional RAN architecture that is called as parang yung non-split type because magkasama po yung baseband unit at saka yung radio unit, no. So this is the configuration in the early stages pa, no, nung 2G at saka 3G, no. Magkasama sa isang parang cabinet, baseband unit and radio unit. Okay, so in this traditional base station, the signal processing, RF equipment, and the network access are found here. And then there will be RF cables, no, from the radio unit papunta sa pinaka-antenna, no. So ang problem dito dahil po, syempre, of course, we know that the antenna tower is has a huge height, no, mataas siya masyado, then there will be a lot of losses here, no, sa ating transmission line, no. Okay, so what they did, no, is to update this such that the radio unit is no longer co-located sa ating baseband unit. Magkahiwalay na sila, no. The baseband unit is here, and then the remote radio unit, yung RRU, or sometimes called as remote radio head, no, are placed now, no, nearer the antenna so that there will be less loss, no, sa remote radio unit, no. Since this is the one, no, na nagko-convert to digital to analog and analog to digital, so ready for propagation na po siya, no. Ayan. So yung naghiwalay sila, no, meron na tayong interface na tinatawag na front hall interface. And then meron pa tinatawag na CPRI interface dito, no. So yung CPRI interface is the front hall interface na proprietary sa baseband and sa RRU, no. So yan, may tatlong components na po tayo, no. Remote radio unit na nearer the antenna connecting to the baseband unit via the CPRI, one of the front hall na interfaces. Ayan. Okay, so this BBU can also be connected to other RRUs, no? Kumbaga, yun yung naging maganda dito, no? Doesn't need to just support one base station. Pwede kung may isa pang base station near as well, no? So RU is moved closer to the antenna to minimize signal loss and nagkaroon na po ng front haul, no? So ito po yung sa traditional RAN natin, no? Okay, so these are the two types as mentioned in the previous slide, no? May non-split, magkasama sa isang parang cabinet, no? Then ito naman yung split architecture na magkahiwalay na yung BBU and RRU. Tapos meron po tayong front hall interface called as CPRI, no? Ayan. Then of course the RAN, no, is connected to the backhaul to the core network via a backhaul interface or cable. So na-discussed rin ni Richard earlier, pwedeng fiber, microwave, or even satellite, no. Yan. Another name for traditional RAN is also known as classical RAN or distributed RAN. Okay, next one is the centralized RAN. So in the centralized RAN, no, somehow this is also known as cloud RAN because all the baseband unit, no, since napaghiwalay na po natin yung RRU and BBU, all the baseband unit can just be pulled, no, nearer the central office para po lahat ng processing, no, mas madali ring ma-monitor na andun lang lahat, no, mas madali ring ma-secure, no. So the baseband units are all near the in the central office, and then pwedeng sobrang layo po nung remote radio units from the central office, no. And then para po hindi masyadong matindi yung attenuation, no, they use mga front haul connections via optical distribution network, no. Gumamit sila ng mga fiber connections po papunta sa mga iba't ibang locations, no. Yeah. So ang maganda dito is it showed that you can pull all the resources in one area and then control all the other na cell sites natin, no. But in this model, no, it's not yet solving the problem of vendor lock-in, wherein if you modify or if you upgrade, if you change no isa sa mga components or some of or the interfaces, then you need to follow still no yung system ng vendor na yon. Ayan. So centralized RAN po ito or Cloud RAN. Okay, and then another parang version of the RAN, no, is the RAN architecture is the virtualized RAN or also known as virtual RAN, wherein the BBUs can still be pulled, no, and placed somewhere else. And then ang nangyari po is the BBUs are COTS hardware running on proprietary software, no, with virtualized network functions. So virtualized na yung functions ng ating BBU, no. So they're not necessarily just one product na BBU siya, but rather pwedeng bumili lang ng COTS server ang ating yung mobile network operator, and then yung software yung nasa loob, no. So kapag may isang nagka-problema na BBU, ang pwedeng gawin is just reset, no, that BBU without affecting all the other baseband units, no. Maganda diyan, pwede rin nila i-pool, no, pwede rin magkaroon ng load balancing na factor diyan, pwedeng mag-shift, no, to the other BBU, yung ibang RRU if may isang hindi operational, no. Yan, so parang somehow, no, this started, no, yung pag-disaggregate na kasi naghiwalay na yung functions, no, ng software at saka yung hardware component, and hindi na limited to just the baseband unit hardware, no, pwedeng COTS server na, no. Ayan. So, hindi pa ito Open RAN because the front haul interface, no, connecting this baseband unit and RRU is still proprietary, no. So, kailangan pa rin sundin yung proprietary software, no. Kaya eventually, no, nung ito po yung comparison, no, ng different na generations ay different architectures natin, no. This DRAN, distributed RAN or traditional RAN, cloud or centralized RAN, virtualized or virtual RAN, and then ito na yung Open RAN, no. So what happens is we have here the front haul interface, no, connecting the DU and the remote radio unit. Then ganun din sa ORAN, no? Hindi lang kita dito, but ang difference nila is that this front haul interface is also open, no? Ibig sabihin, they follow, hindi siya proprietary, hindi siya just for one vendor. Yung specifications niya, yung physical and kung naman yung specifications ng front haul interface, no? Yeah, so to summarize the architecture evolution, no? Originally, traditional RAN, no, has these two types, non-split and split. All of the components are proprietary. Centralized RAN, ganun din, all components are proprietary. But what happens is the baseband units are centralized or pooled together in a different location para mas efficient po yung pag-manage ng different sites. Virtualized RAN, wherein you now introduce COTS server, no, to allow virtualized network functions. And then Open RAN is that we now have the components into COTS-based hardware, and then the functions are virtualized. And then there's now an open interface, no? And so later, titignan po natin specifically, no, yung mga components under ORAN, no, like itong radio unit, distributed unit, and centralized unit, no? Then ang maganda rin sa Open RAN, no, depending na lang kung saan nila gustong i-deploy, no, maybe the mobile network operator wants to deploy this to the RU and DU nearer the antennas, or baka gusto nila RU lang yung nasa antenna site, no, or pwedeng lahat, no, sama-sama like small cell lang, no. So kung paano yung pagkakahati-hati, no, where they are located, no, that's also defined by 3GPP as the functional split, no. Okay, so this is also, no, the summary of the architecture evolution. We have in the traditional RAN, no, all the components are proprietary. The RRU, the baseband unit, and the front haul. Ganun din for centralized RAN, no, lahat proprietary. Nagkaroon lang ng update, no, which is yung BBU pooling, and then distribution network in front haul, no. Virtualized RAN, all again proprietary. So ang hindi proprietary is yung hardware ng baseband unit, no? And then finally sa Open RAN, all the hardware and the interface are open, no? So itong hardware ng RRU, hardware ng BBU, and then front haul open din, no? So yung software okay lang na proprietary siya, since yung operation naman, yung main motivation talaga ng RAN evolution is kailangan madaling mag-interoperate yung iba't ibang devices, no? So, hindi ka dapat naka-lock-in sa isang vendor lang, no? So, as long as all of them, no, can operate, physically connect to each other, then it's okay to have a proprietary na software, no? Okay, but essentially Open RAN, lahat po ng hardware, including yung interfaces, they should be open or commercial off the shelf sila. Ayan. So, yan po yung motivation o yan yung architecture evolution ng ating ORAN, no? Kung yung ating RAN. Okay, and then now let's proceed na dun sa pinaka-heart no, nung course na ito. No? Ito po yung important, very, very important na part ng ating course. No? Which is about the architecture of ORAN itself. No? Okay, so we already know that radio access network or RAN is here, no? Ito pong color red, no? This access network is the one connecting our end user or the user equipment, no, to the telco system, no, via radio frequency. No? So the access network or the radio access network connects to the core network via the transport network or also known as the backhaul. No? Yeah. Okay, so ano po yung main RAN components, no? Pag tinignan po natin yung loob nitong access network, no? Ito po yung main components natin, no? The baseband unit and the remote radio unit. No? And earlier we already show, no, that nung naghiwalay itong dalawang to, na-introduce yung ating front haul na interface, no? So may backhaul tayo sa likod, yung papunta sa core, yung front haul naman, yung papunta sa remote radio unit, no? Yan. Okay, so napakita din to no in the previous course yung parang different interfaces and different components no. This is one way of viewing it no. So we have the core network involving various na high performance devices. And this is not covered no, in our course since ang main focus talaga natin is the RAN no. This part near the user equipment no. Okay, so the core network connects to the RAN via the backhaul. And then inside the RAN would be different components, no? Yung dalawa would be the remote radio unit and the baseband unit. And in the course, you'll also learn, no, ano po yung pinaka-functions ng remote radio unit, no? Like, ano yung naka-assign sa kanya, no? Is it focus on analog to digital conversion or digital to analog conversion, mga physical layer protocols, and so on. Okay, and then we already know that RRU and BBU are connected via front haul. And then later, nagkaroon din po ng parang disaggregation si BBU. So medyo marami kasing parang functions, protocol pa si BBU. So pwedeng paghiwalayin siya further into DU and CU or distributed unit and centralized unit. Yan. Tapos nagkaroon ng mid-haul. No? So tatlo ng interface, no? Yung main interface, front haul, mid-haul, and back haul. No? Connecting yung RRU, DU, CU, and the core network. No? Yan. So bakit pinag-iwa-hiwalay? Kasi later maaaral po natin no, yung tinatawag na functional split. Pwedeng piliin ng mobile network operators no, kung anong mga functions yung ilalagay sa bawat component para maging mas flexible no, yung sa deployment scenario nila. Depende kasi kung ano po yung needs no. Maybe on the particular service area, hindi nila kayang ilagay yung buong RAN. So they can just put in the remote radio unit near the service area and then the DU-CU maybe just in their central office no. O kaya naman kapag small cells, usually sama-sama na yan no. Like yung mga in-building na small cells natin, lahat sila sama-sama na, then that means hindi na kailangan talaga ng pagkakahiwa-hiwalay. No? So mas flexible na no, yung ganitong setup. Hindi siya fixed na dapat sama-sama sila in one location or dapat sobrang laki ng device or something like that. No? Yeah, so ito po yung mga front haul no, or FH, MH, saka BH. Yan. So pagdating nung sa ORAN, no, they introduced more components, no? Nagbago lang ng konti yung mga CU, DU, RU, no? Nagkaroon lang ng O sa harap, no? So ORAN centralized unit, ORAN distributed unit, ORAN radio unit, no? Or remote radio unit, no? So ito po yung parang ano lang muna, overview of the architecture, no? Para hindi po nakakabigla, no? Kasi later makita nyo, mas marami pang components, no? So in RU tsaka DU, di ba, ang nagko-connect sa kanila is FH, yung front hall. So in ORAN, nagkaroon lang ng prefix na O to mean it's now open front hall. No? Kasi in the discussion po in this course, may iba pang interfaces na front hall and then some are not open. No? So dito ini-specify na dapat open yung front hall na gagamitin for ORAN architecture. And then ito po yung CU natin. No? And then it's composed of the control plane and user plane para po ma-separate yung parang processing ng mga overhead. Yung isa is focused dun sa data of the user. No? So ito po yung main, no? Yung centralized unit natin. And then the mid-hall interface again, no, is connecting the CU and DU. This one, no, is what we call the F1 interface, no, defined by 3GPP. So ulitin ko po, no, ito po yung front hall, ito po yung mid-hall, no. Mid-hall is F1, no. Yun po yung name niya talaga. No? Mid-hall is the generic term, no. F1 is yung specific na interface, no. And then, connecting this CU papunta pa sa ating core network would be the backhaul, no? Pero pagdating kay ORAN architecture, nadagdagan itong mga to, no? Itong SMO and itong near real-time RIC, no? Anong purpose po nitong mga to is for optimization itong RAN, especially kapag sobrang dami na kasing components and they need to monitor, manage po yan lahat, no? And it's easier to manage if merong parang other components, no, to monitor their operations, no? Yan. So SMO or System Management and Orchestration, this is responsible for the RAN domain management. And then inside it, meron pang tinatawag na non-real-time RIC, no? Okay, so madi-discuss po yan later and also ma-emphasize din siya doon sa next course, no, yung i-overview natin next week. Yan. So yung NRT or Near Real-Time RIC, it supports tasks that require less than 1 second latency. So kung naman yung mga task na requirement nitong RAN, para ma-optimize yung kanilang operations, like for example, yung mga pag-manage ng mga channels and so on. No? Anything that needs almost real-time na response, ito yung nagpo-process. No? This near real-time RIC can also connect to other nodes. No? Kasi ito, this is just one node. No? Parang one base station siya. Meron pa pong ibang base station. No? Ayan. Sige po, may question po ata, no? Maybe you can chat po, no? So that I can read po in a bit. No? Okay, and then, what else? Sige. Okay, so siguro we can go, no, dun sa parang architecture na, no? Ito po yung architecture without the interfaces, no? So nabanggit na earlier, no? Meron tayong CU, DU, RU. Humaba lang yung pangalan po nila kasi nagkaroon na ng ORAN sa harap, no? So still, RU and DU is connected by the front hall interface. Tapos yung centralized unit natin, napaghiwalay lang, naging control plane saka user plane para lang mapaghiwalay yung functions nila. No? And then this CU connects to the DU via the mid-hall interface. No? Yan. So ito pa rin naman yung tatlo kanina. No? Nadagdagan lang po talaga tayo ng other parts. No? May kulay na rin siya, no? Kasi this is also what the ORAN Alliance use, no? Para consistent po at mas madali natin maalala, no? Ayan. Okay, so may ORAN cloud infrastructure as well, not part of the ORAN itself or the RAN itself, no? But pwede kasing magkaroon pa ng mga cloud native virtualized functions dito. Yan. So ito na po yung pinaka-important na slide sa ating course. No? This is the ORAN architecture. No? Kaya hindi ko po siya agad pinakita immediately, no? Kasi maraming components and maraming interfaces dito. No? And actually, ito po isa sa mga assignment do sa course, no? To draw this architecture and then explain po yung bawat parts. No? So that mas ma-familiarize po siya, no, nung learners and also mas may retention, no, if we handwrite the content. No? Ayan, so simulan ulit natin sa RU, no? So RU, radio unit. Again po yung O here just specifies na nasa ORAN na architecture na kasi, no? RU and DU, distributed unit, is connected by the front hall interface, no? Dapat open front hall interface. Meron lang parang dalawang planes para paghiwalay lang yung parang yung M plane, management plane, saka itong control user and synchronization plane. No? But essentially, ito po yung front hall natin. No? Notice yung mga interfaces, may mga parang color, ano pa sila, no? May legend pa sila. Kasi yung mga gray dyan, those are defined by 3GPP, no? So ito po yung talagang architecture before ng RAN, but minodify siya ng ORAN, no? So that we can incorporate yung other functions pa, no? Other nodes natin na introduce, no? Okay, and then we know the DU is connected to the CU. And in this case, yung CU has two parts because of may set ano tayo dito, no? Control plane and user plane. No? So yung ating mid-hall interface is the F1. No? Dito may dalawang F1 lang. Isa kasi control, isa naman user. No? Ayan. So bali ito na yung run talaga. No? Yung CU, DU, RU. But as mentioned earlier, no, para mas ma-optimize yung operation niya, and syempre may mga virtualized network functions siya, no? Pwede kasing i-optimize yung mga yon, no? By understanding the whole network, no? Including other nodes, no? Gumagamit ng near real-time RIC, no? So ito po yung mga different na, ito yung mga different na task, pina-perform na task ng near real-time RIC is anything almost real-time, less than 1 second, para po ma-optimize operation nito, no? Okay, and then notice no yung near real-time RIC has an interface called E2. E2 is the interface connecting to the RAN, no? So yung papunta sa CU, papunta sa DU din, no? So ang nangyari is kinukuha niya yung mga data and then pinaprocess niya yon, tapos it can send updates, no? Tapos itong mga virtualized functions to may updates sila from time to time, no? Para if for example maybe one of the virtualized functions goes down, then pwedeng mag-optimize for load balancing and so on, no? So dito na nagkakatalo-talo, no? Ano yung software, yung proprietary software that can help na optimize talaga, no? Pwede magkaroon na po dito ng AI, ng machine learning na aspect to optimize, and maybe magkaroon din ng other na applications pa, no? Okay, and then ito, no? Remember E node B. Yan po ang base station, no, para sa 4G. So, pwede rin pong kumonek yung ating near real-time RRC to other nodes, no? So, ito kasing tatlong ito, or apat na yan, this is just one node, no? Parang one base station, no? Pwede pa sa iba pang base station. So, may iba pa dyan, no? Pwede mas marami pa, hindi lang dalawa to, no? So, you can connect as well, no? The near real-time RRC can also get data from other nodes, no? Via the E2 interface, no? Bale, itong part na to, no, yung ORAN eNode B, contains as well inside are the CU, DU, and RU. No? Ayan, so marami-raming interfaces po, no? So meron din as well E1. This is just the interface connecting the control plane and the user plane. And then meron pa po ditong X2 at saka NG na mas madidiscuss no kung cover po natin yung ibang slides, no? But these are the connections as well na to other na other nodes, no? Yan. Okay, and then what else, no? Yung near real-time RIC is yung real-time na late na task nga, no? Less than 1 second po yan. But meron po tayong non-real-time RIC, no? Ito po yung mga task na magre-require ng longer time para ma-complete. Dito po yung lang po. So dito po ma-focus yung ayun lang po may tumawag bigla. Okay, so yung the non-real-time RIC are tasks that require more than 1 second. For example, if you need to have traffic forecasting, no, or parang user management, no, or anything pa no, na magpe-predict or something else, no? Nandito po yung mga tasks na yun. So, ang nangyari is kukunin niyo yung data, no, or other important analytics pa, no, sa near real-time RIC via A1 interface. Yan. So, ito po yung mga interface na yan to show the connections and pakita, no, kung ano po yung mga may mga relationships dito, no. Yan. And then, ito po yung service management and orchestration. Mas marami pa siyang ginagawa, no. May mga connections din like O1 plane papunta sa other nodes, no? And then O2 plane papunta sa Oak Cloud. Parang dito na po yung mga cloud na functions, no? And so on, no? Okay, so bale, yung RAN natin before, no? Ito pong part na to, no? Yung color red saka orange. These are the components of the traditional na RAN and yung other RANs natin. But when we go to ORAN, no, nagkaroon na po ng mga new interfaces and new components, no. Ang purpose nila is to optimize and also parang magamit further pa yung mga virtualized functions ng ating RAN, no, para mas ma-improve yung mga performance, ma-improve yung traffic, ma-improve yung user experience, no. Ayan. So, you can visit, no, ito pong ORAN architecture. Siguro let me send the link sa chat, no? Sandali lang po. Copy ko lang po na yung link. Ay, sandali lang. Okay. So, sinend ko po sa chat yung link, no, dito sa ORAN architecture. Ayan. Kaya po hindi ko siya agad pinakita, no, kasi upon initial look, no, parang daming components. But essentially, no, you can separate them into different parts naman, no. Ayan. Okay, so may 10 minutes pa po tayo, no? Let me go into other details pa about the architecture. Ayan, so ito parang another way, no, of looking at the architecture. This is what we call the ORAN Alliance Reference Architecture. Hindi pa nga siya yung complete na reference architecture kasi gusto ko muna mapakita sa inyo, no, yung how it is related dun sa kanina, no. So halos pareho lang siya, yung color coordination same. May SMO tayo, non-real-time RIC, near real-time RIC, connected by A1. Yung RIC natin, yung RIC natin connects to the CU and DU. So yung ating CU may contain multiple radio access technology na multi-RAT. So ito po, it just means, no, it's not just 5G, we can also have 4G or 3G, no. Originally, the ORAN system is focused sana on 5G, but eventually they were able to do something, no, even for 4G and 3G, no, para lahat po ng protocols or lahat ng generations magi open din, no. Yan. Okay, and then we have the distributed unit, no, connecting to the CU. So CU to DU is the mid-haul. Another name for the mid-haul interface is F1. This is specified, no, by our 3GPP, no. And then the front haul interface connects the DU and the RU, no. Yan, ito po yung pinaka yung detail na ng ating reference architecture. Inside the SMO, may mga design, inventory, policy, configuration, and so on, no. So medyo mas long term, no, yung kanyang operation, no. Then ito na yung ating near real-time RIC, mostly focusing on tasks na kailangan i-resolve agad, no, like radio management, mobility management, quality of service, interference, and so on, no. Possibly, no, yung mga data na nakuha nitong non-real-time RIC, pwedeng gamitin for creation of machine learning models, no. And then those machine learning models may be updated, no, sa ating near real-time RIC. Pwedeng itong mga trained model na to is coming from the non-real-time RIC. Tapos, yung model na yun i-apply, no, para po ma-optimize, no, and ma-manage yung ating mga DU and CU, no. Ayan. And then ito po yung ating CU, no? May control plane and user plane, no? Connected by E1. And then itong mga to are protocols, no? Later po siya, no? If na makapag-enroll na kayo sa course, di-discuss din po yung mga protocols na yan. No? Yan, notice yung E2 connects the near real-time RIC, saka yung CU and ang DU. No? And then, F1 is the mid-haul interface. No? Tapos pansinin nyo yung ating mga CU or COTS, no? Platform. No? And then DU is the one performing usually these protocols, yung RLC, MAC, physical, higher physical layer. Much later po mas mako-cover po ito, no? But essentially, yung ating RAN, no, has different protocols that they need to perform para magawa po nila yung kanilang task, no? And due to the functional split, pwede pong mahiwa-hiwalay, no? Alin po dun yung ginagawa lang ng RU, alin ang ginagawa ng DU and yung CU. Depende po kasi dun sa parang use case ng mobile network operator. Ayan. So ito po yung isa pang assignment actually, no, kung kailangan yung learners, no, they draw this, no, at the start, probably they don't understand a lot of the details, no, but eventually because they will draw them and try to understand each connection, no, mas ma-absorb po nila yung architecture this way. Yan. So, bale ang important na part po dito sa course would be this slide, no? And then yung ORAN architecture earlier, no? Ito pong slide na ito, no? Showing the 3GPP nodes, 3GPP interface, ORAN interface na bago, yung mga color green, and yung mga ORAN nodes, no? Like yung RIC, saka SMO, no? So pag ORAN, basta may O sa harap po, no? Pag 3GPP pa lang, wala pa yan, no? Hindi pa nilagay yung O sa harap, no? Ibig sabihin, the nodes are not yet open, no? More likely, they follow the proprietary na version, no? Ayan. And then, siguro let me discuss, no, some of the working groups, no? Si ORAN Alliance include some working groups. No? They are in charge of yung pag-aaral ng mga different parts of the ORAN architecture. Like ito, working group 1, mga use cases and overall architecture. And then we have working group 2, they only focus on the non-real-time RIC saka A1 interface. No? So pag binalikan po natin yung reference architecture, yung A1 interface, or yung ating, architecture pala, no? A1 interface is this interface here, no? Connecting the two RICs. Ayan. So yung prepare ng mga specifications saka nung ating mga details on this, no, is from working group 2, no? Ito po yung kanilang focus, no? Working group 3 is more on near real-time RIC and E2 interfaces. Remember, E2 interfaces is yung interface connecting yung ating near real-time RIC papunta dun sa CU at saka DU. Ayan. So, ito po yung part na yon, no? So, near real-time RIC, yung E2 interface, papunta sa CU, saka sa DU, and as well as other nodes pa, no? Yung CU, DU po nung other nodes na yan. So, hindi lang siya nag-manage ng isang RAN, no? May iba pang RANs na pwede niya i-manage. No? And then other working groups, no? Like ito, working group 4, open front hall, working group 5, other interfaces pa, like ito, mid hall, and so on, no? Okay, so, these are other working groups, but not much focus sa ORAN, no? May, ito is for orchestration, and so on pa. So yung important for this architecture would be this first 5 na working groups natin. No? Ayan. Okay, so siguro to summarize, no, let me use this slide, no, para ma-end po yung discussion, no. So originally, no, we know that we have BBU and RRU. Ito po yung split architecture ng ating traditional RAN na may front hall interface. No? So front hall interface, one of them is yung ating CPRI. No? Proprietary po yung tatlong 'yan. Kaya, later nagkaroon ng ORAN para mas madali po magkaroon ng, changes sa network, mas maging, modify ng mobile network operator according sa use case 'no, baka dun sa particular service area, they can only accommodate RRU 'no. And then eventually they have this 3GPP approach na specified in the technical report 38.801 wherein the BBU, yung baseband unit natin, na paghiwalay further yung functions niya into CU and DU. No? Yung centralized unit and distributed unit, no? They have a mid-haul interface here. No? Ayan. So this mid-haul interface is yung ating F1 no, interface. No? So ang maganda dito sa TR, no, yung technical report na to, yung mga functions nitong mga to may vary depending on ano yung split. No? Bale yung mga lahat ng mga applications or rather lahat ng mga functions nila, lahat ng mga protocols na kailangan i-perform nung run, pwede pong mapaghiwa-hiwalay yun, no? Depende na lang sa use case, no? Baka yung DU na hardware nung mobile network operator hindi kayang i-perform lahat, no? So maybe it will only perform a certain portion. Okay, so ito po yung isa sa mga critical na or parang important information sa ORAN architecture, no? And makita nila no, the reasoning behind having this one.